I'm really fluctuating or oscillating, if you will, between the good mood when I see things funny way and the world seems good, but then I also come into state when I'm a little down because the things are happening, so much violence, the nature of humans. And I would say just one sentence that we who remain, we need to fight on. We need to go on no matter what. So today I presented the lecture and we will move to the table. So let us begin. It's about gravity. Well, before we begin with gravity, I would like to touch the intelligence. And I was asking myself a question, who is the smartest person in the world? And I come to the conclusion that probably no one is the smartest because the intelligence has many different levels. For example, you can be very intelligent in math and physics, but you can have very low social skills or politics or law or whatever. So it can vary, and I would say that it really is a specialization that someone is smart for that, someone is smart for other things. But in the politics, overall, I would say that it's a, Gaussian curve. We have the average, which is here, and this is 100 IQ, and then some have 110, 120, and less have more. And then you have the other side, where people are not so smart. And what happens if you have, for example, a president? I think president is not the smartest person in the world, because he or she doesn't need to be. He has advisors and everything. The point is just that he's good or she at processing information and understanding, that have just common sense or critical thinking about the speeches that are made to him or her, and that he realizes that, if something is suspicious. But what happens if you have a president with IQ 90 or even 80, or I think we can go down to 70. That I think happened with President Nixon, and he was about to be impeached, but he realized the situation, so he resigned, and I think that was a really good thing that he did. So I want to take attention here. Things will happen how will be. I think that Senate and Congress, they're here, and this gap will become evident more and more. But I think in the future, we are moving the curve even here. So maybe in the past, if you have IQ 110, now it's only 105. Like inflation, for some sense, it's working, I would say. So we won't waste time here. We will begin with physics and gravity. Yes, in the 17th century, Newton discovered the famous equation of gravity, universal law of gravity, and it says that the force between two masses is, according to Newton's second law, is mass times gravitational field, gravitational acceleration, and this is the same as gravitational constant times mass of one object times mass of the other object divided by r squared. So for example, if m is the mass of the Earth, capital M, and the m is the mass of the Moon, then r is the distance between them, and you get the force, or here just gravitational acceleration, and we can write this gravitational acceleration is g m divided by r squared, from where we can see that it depends only on the mass of the Earth. So that's why the objects with different masses fall with the same speed, the same acceleration, so they fall simultaneously, if you not consider the air resistance. For example, if you have a feather and an iron ball, of course feather will fall lower, but if you won't have air, if you put it in a vacuum, they will fall at the same speed, at the same time they will reach the end. And if we draw an earth here and say it has a radius capital R, then this law says that gravitation is proportional to the inverse squared law, which looks like this. And here at the surface of the Earth, the gravitational acceleration is 9.8 and something. And if we move here, let's say 10,000 kilometers from the Earth, it is only about 1 and something. So, and the Moon is much further away, I think 300,000 kilometers or something, but that's the pool still works because they are so massive objects. But what about the center of the Earth? Well, if you think logically, as Newton did, at the center the gravity is actually zero because you are surrounded by the same amount of mass from all sides. And how to prove this? Well, simply we write mass as density, rho, Greek letter, times volume. And we know from the previous lecture that the volume of the sphere is 4/3 pi r to r cubed. And from this we express the density. You can do it by yourself, I won't do this. And we say that actually here, if it is with Earth, and if we move with R inside the Earth, this is Newton's surface law, or something like this. This mass doesn't contribute, only this mass in the inside contributes. So that means that M of enclosure, this M of enclosure is actually density times, again, 4/3 p small r on 3. And inserting here, we get finally that G inside is G times R divided by R cubed, which means simply that it's linear, like this. And of course the density inside the Earth is not uniform. We propose this as it will be like it is uniform. It is actually not, because the Earth's core, inner core, is solid, contained with iron and nickel, and the outer core is made also from the same elements, but is liquid, and because it's moved, it creates a magnetic field which protects us from the sun's radiation. And if you have, mass is an integral 0 to r. If it's not uniform, but it changes to r, it's like this, times 4p r dot squared dr comma, or how to say this. And this is actually the area of the surface of the sphere. And Archimedes showed that the surface of the sphere, if this is cylinder, this cylinder in 3D it would look like this. And if you put the sphere inside, and if this is R, then he showed that the outer surface of the cylinder is the same as the surface of the sphere, and this is 4 pi r squared. So in that case you use this formula. And as I said, the further lecture, the further story will be about the gravity. You will see. I hope you will like it, as always. And for the end, I prepared my happy mood, how it looks like. And so you will see that sometimes I have fun with all of this, and I hope you're having fun too. So thank you for your attention, ladies and gentlemen, and see you soon. We are cooking mushrooms today, special, so I'm really happy. I can't wait for the dinner. Well, this is how it looks when I'm really entertained by the by the ideas they bring. So good work, team. Just keep on like this. Really interesting.